So far, we have a model which says that a house price equals $100,000 plus $9.3 per square foot of lot area. That's not a very useful model. It doesn't take into account the number of bedrooms or the number of kitchens or a million and one other factors. A model might look something like this, that price equals $100,000 plus $9.3 times lot area plus $10,000 times the number of bedrooms plus $20,000 times the number of kitchens. The kind of real estate model that is being used in practice nowadays would have hundreds of variables like this and would be far more complicated. But this model has 3 variables, and therefore it is called multiple linear regression, and that's what we're going to look at next. In general, we might have something like this, where the price y depends on beta naught, which is the intercept, plus some coefficient, beta 1 times x1. x1 might be lot area, plus beta 2, that's another coefficient, times x2. x2 might be the number of kitchens, and so on and so forth. Now, how do we go about solving this with gradient descent? Well, first we need to write this in a bit more compact fashion. If you remember your matrix multiplication, you'll see that we can write it out with 2 matrices, or you might call them arrays if you were working in Python. First of all, something which contains all the features. If you remember, x1 might be lot area. We also interestingly have a 1 at the beginning. That's to help us deal with the intercept. So we have all the features together, and then we have all the coefficients together. Now, if we have information for lots of houses, we can express that in a somewhat messy looking but rather compact way. y1 is the price for house 1. The first row of this big matrix over here is all the information for house 1, and when you do your matrix multiplication, that will be multiplied by the coefficients to give the price for house 1. The second row is the price for house 2. Here is all the information about house 2, and again it's multiplied by the coefficients, and so on and so forth. What we can now do is we can say that this massive matrix in the middle will be called X, and the matrix of coefficients will be called beta. We then end up with a very compact way to express this model. Y, which is the array of all house prices, equals X, which is the matrix with the information about each house on a separate row, times beta, which is the array of coefficients. In Python, if you require predictions, the array of predictions can be calculated as follows: x dot beta, or whatever variable you store your betas in. The gradient of this system is given by -2 times the transpose of x times the array of prediction errors. In Python, this can be written as -2 x dot t, where the dot t is the transpose operator, dot errors. And finally, the sum of the squared errors can be written as follows: errors transposed dot errors. That's really all we need in order to implement gradient descent in Python. We're going to go over there and do it now. It would be a good idea if you tried to go through the notebook yourself. There are enough hints in there that you should be able to get through to the end. So give it a go first. If you get all the way through, that's fantastic. Otherwise, have a look at the solution that I will provide. After that, we're going to go straight into sklearn again and do it the easy way, multiple linear regression with sklearn. And after that, well, I think you've gotten quite far, and it's probably time for a break.